Hey guys, so today we're going to be doing a quick demonstration of LMI's Gocator snapshot sensor, the 3210. This is a structured light sensor with a projection technology and two cameras triangulating the position of that fringe pattern onto the part. So today we'll be scanning the Spartan Race medals, and I'll give you an overview of how this data looks in the web interface, and we can take a look at some measurements as well. With the structured light, we're going to be able to take a scan. We'll see an initial image pop up, and this is showing up based off of the orientation it is relative to the sensor. If I rotate this a little bit, we'll see that the orientation of the image updates in this case. Now, if parts are coming down in different orientations, I want to be able to account for that. So now that I have this first image, I'll show you how that's done. So now that we have our first image, we're going to go into our measure tools, and we're going to start applying some features that allow us to use a transformation to reorientate this part the same way every single time. So I'm going to pick up, in this case, a surface hole feature, and we're going to look at the entire region, and we're looking for that 3mm hole at the top there, at least as far as the radius goes. So now that we found that, the next one we're going to use is a surface circular edge, in which we're going to find the let's say radius or outer portion of this metal. We're going to use this as our search region. We're going to use 6 calipers, and we're going to change the caliper sizes to find those edges. And because we're looking at an outer radius, we're going to be wanting to look inward to find that edge, and then we'll also filter for some noise. Now we have 2 circles, and these 2 circles have a point associated with them. We can now create a line between those two. So we'll use the feature create. We'll go ahead and create a line from points, and we'll use these 2 holes to create a line. And we'll apply that here. So we have points, we have a line, and the final dimension that we'll need to control is a plane. So we'll go ahead and create a surface plane tool. We'll go in here and add that to our tool set, and we'll want to look at this entire region, or at least look at this data and create an average plane throughout it. So if we were to reorientate this, we can see that it cuts a plane right through that surface. Now that we have these 3 degrees of freedom, we'll go apply a surface transform tool. And what this allows us to do is use those features as inputs. And we'll go ahead and input our plane, our line, and then we'll use the top ring as our hole feature for our main point to utilize as the alignment. So we'll see the coordinate system adjust based off of these selections. Now when we go to the data output for this, we'll see that it reorientates the image based off of that coordinate system center point. Now I like my images to look vertically, so I'm going to go ahead and use a fixed transform and rotate this image around 270 degrees. And there we go. So anytime that we scan this part, it's always going to show up in this scan orientation no matter which position the part is scanned in. So I can rotate that a little bit here, take a new image, and we'll see that the new output is in the same location every single time.